It's my pleasure to introduce you Henk Spy. He is a retired senior software engineer and a development manager. He was educated as senior electronic engineer and has over 30 years of software development experience in embedded industrial and customer solutions. So it's my pleasure to give you the floor, Henk.
Well, welcome everyone. It's quite a few slides, so I'll probably go through it fairly quickly, and a few slides a bit longer. At the end of this presentation, you should have a good idea what HiveOT means, what it's intended for, and how it uses the WoT TD to make things go around. I'll have a little demo in the middle, near the end, and then it closes off with a set of challenges that I've encountered while developing HiveOT. They apply mostly to TD, my favorite topic forms. So it will be quite interesting for those that'd like to know more about those topics. So let's start with the introduction. I'm the author of HiveOT. That's for me started as a side project. As Cristiano said, educated as electronics engineer. That was in the early days, but I kind of defected to software development quite early on. And somewhere further down the road, ended up in management. Yeah, if anyone offers you that, then think twice unless you really enjoy it. Speaking of enjoying it, I love the coffee. IoT has always been my favorite topic. Open source software, Linux, and Golang is my favorite programming language. I've had quite a few over time, but Golang gives me the least headaches and gets things going fast. And of course now the Web of Things is very popular. So I've started that 2 years ago, diving into that, but it is not my first foray in IoT. So why did this come about? Well, this was actually happening. I bought a piece of land, had a pump house, built a pump house on it, the one you see in the picture. And of course, the house itself is a bit further away. And if something goes wrong in that pump house, then, well, I'd rather be ahead of the game than finding out that the water is frozen. It's also a little bit out of sight, so it'd be nice to know if it has any visitors, animal or otherwise. So, well, of course, what do you do as a software developer? You build stuff to solve these questions. So it actually started with other projects. There's been several iterations, and initially it was more driven by curiosity as what is possible, what technologies are available, what communication protocols, what standards. So it started off, I couldn't find anything in the early days. That was around 2015. And then I started basically using MQTT. In my zone, I used that version quite a while locally, so for personal use, but that was still MQTT sending messages around, and there's no standardization. So then in 21, I found NGSI LD. That was my first standardized version iteration. Went basically between messaging based, message bus based to API based, which is NGSI SI. gRPC and CAP and Proto are RPC based. And now what I really like about WoT is that you're not tied to a single protocol. So it's protocol agnostic, so you can plug in any protocol adapter and work with the stuff that you do. And that's the final version. So what is HiveOT? Well, it's an edge device, intended as an edge device, not as a central server that connects consumers with IoT devices. I don't know if you guys can see a cursor. I assume not. In the diagram on the, good.
Yes, we can.
The IoT devices can be anything. I'll get a bit deeper into that in a minute. It doesn't have to be a WoT device. In fact, the assumption is that most of them are not. So it will accommodate many more. And of course, ideally, there's many WoT compatible devices to come. The hub itself acts as a hub, not as a So the consumer connects to the hub, and the hub talks to the IoT devices and services. At the moment, there is no internet gateway, but that is planned for the future to be able to join multiple hubs where desired and share select information. The idea is that consumers connect directly to the hub through a web browser or command line interface, or other services connect to the hub to get access to IoT devices. So what's the goal here? Well, sharing information between IoT devices and services and consumers, whether that is a BI system or whether it's just a simple web browser or something that sits on the coffee table that shows you the current weather forecast or anything along those lines. Could be anything, but it is about information sharing. It's currently based on the WoT TD 1.1 specification, including support for discovery, and now more focused on various protocol bindings. The latest Pan-Francis proposal for the WebSocket based protocol, which is currently working, but of course that specification is in draft and things are fluid. The other interesting bit about it, it has a digital twin representation. So it doesn't really connect consumers directly to the device. Consumers actually talk to a digital twin. And I'll get a bit more into that itself. That gives you a lot more capabilities and interesting options. Another objective is it's lightweight and minimal dependency. The core itself is written in Golang, and it's basically just a binary that you run. It doesn't have any further dependencies, except at build time, of course. The binary is about 10 meg, and then each service as well, and that comes from mostly the Golang runtime. It's extensible because, as you see in the picture, the services plug into the hub, but you can add any services at any location on the network. So these services can talk to things on the digital twin, things, and send actions, get updates on properties and events. And it is intended to be secure, and I'll get into that a bit more as well. But the bottom line is the biggest aspect of security is you can't talk directly to the devices themselves, and this is where you kind of little deviate from what the WoT normally does or assumes. And correct me if I'm wrong, but the current design of WoT is focused around devices running a server and expose a thing and their TD and interaction. What HiveOT is centered around is that consumers only connect to the HiveOT, to the digital twin hub, and the hub connects and communicates with all the devices. So you can put these devices behind a firewall or hidden on a local network and reduce the footprint and therefore the security risk. The other benefit we'll get to in a bit, but it's nice for consumers. You only have to deal with one endpoint. So I touched a bit on security. There are concerns that everyone, I'm sure, will share, and it is the ability for many existing devices to be hacked. So the attack surface, if you have 1 billion IoT devices accessible directly or indirectly from the internet, I think I'm a bit concerned. This is a big problem in the making, especially once you get behind the initial firewall and I have access to IoT devices, and a lot of them are weak in terms of security. Security is not something you just tag on. It's quite complicated. And the other concern is that a lot of these devices, you're lucky if they get firmware updates. Now, the WoT does a good thing in standardizing the behavior around firmware updates, so hopefully that will help. Quite often, authentication is weak, like hard-coded passwords and that stuff. Security cameras are the worst. And the lack of encryption, and there's many concerns that relate to existing world of IoT devices. The best example I thought was a casino database of a hack, is that the casino database was hacked through a smart fish tank thermometer. That actually happened. I got the link to the article, but it just shows you that once you have an IoT device to the network, connected to the network, yeah, you better take a close look at security, especially on a company side or a casino in this case. Sorry. So what does HiveOT, what approach HiveOT takes? Well, the main thing is that in HiveOT, things don't run service, or if they have to, if they do, then you put them behind a network and no one else can touch them. The model is that IoT devices connect to the hub, and this is only one way to connect to the hub, but that's the ideal mode so that the IoT devices don't have to run a server. Now, that's pretty much in the future, I suspect that most IT devices will run servers. I've got a solution for that embedded in, and that is through the services capabilities. We'll get to that in the following slides. But if you don't have to run the server, you use less memory, your devices can be cheaper. You don't have to worry about security as much. The only thing you have to do is discover a directory and connect to a hub. So the benefit is that the attack surface of all these IoT devices are greatly reduced. There's simply no access to the device, so it can't be hacked that way. Doesn't mean it's fully hack-proof, but it really helps. And everything with HiveOT is always encrypted SSL. So just the use of the hub adds some benefits. You centralize authentication and authorization. So rather than having to figure that out for every single device, you can centralize that. And as a consumer, you only have access to the hub, and you need your access credentials, and that's it. Your connectivity is simply with the hub, as I mentioned before. So there's one set of security protocols. Firmware updates can be centralized. The user interface and all the interaction experience is uniform. Whereas if you have different devices from different makes, you will encounter a lot of different varieties in the user interface and how they are set up and provisioned, etc. So I mentioned earlier that HiveOT Hub is an edge device. So that just means that it doesn't have to sit in a big server room. You can have multiple spread around on the network and have them connect to each other. So what does this exist of? So as a ecosystem, the HiveOT, you have IoT devices that are connected. There is the hub itself, which has transport protocols and a runtime. There are some services that plug in that provide essential services. Of course, there is a digital twin with the TD of the device and the digital twin TD. So the thing description document. There's some middleware to handle communication, and of course, there's consumers. The transport protocols on both ends. So the consumer has a choice of transport protocols, and so do the devices. So that means that you don't, as a consumer, you don't really care about what the protocols the devices use. You just connect to the hub. Now you also see on the left here, on the protocol plugins, you have, of course, the Web of Things, but you also have things like Z-Wave, Insteon, OneWire, and that's basically, you have bindings, protocol bindings that transfer or map between the native protocols of these devices, like Z-Wave. You have those USB sticks, you plug those in, and then the service connects to it and then translate that to a thing description document and events, actions, and properties. So that's the role of these drivers, so that consumers can talk to basically any protocol as if it was a thing, using the WoT standards. Now, that same goes for WoT devices that have servers. So a binding will simply do the discovery on the network, find things, extract their TD, and communicate with them as if it was a consumer. So the runtime here has two phases. There is the consumer-facing side in which it acts as a server and exposes multiple things through its directory. And there is it's a consumer itself of all the things it can find on the network. The services, they basically connect to the runtime through the standard API, through the exposed protocols. And they can offer capabilities, expand capabilities, like I'll have a little quick demo with the web browser to provide a user interface that has a history service that tracks all the events that are emitted. So you can go back in time and see what happened in the past. There's a launcher through which you can start and stop in the individual services and bindings. Excuse me. There's a provisioning services for automatic adopting devices on the network. A certificate management that could need a bit more work, but the whole idea is that eventually if you want to expose over the internet or a port, and you want to have a proper certificate for the SSL connection, and that service can take down that role. And then there is a monitoring. You could add simulation, because now you have a digital twin. You could kind of substitute an existing thing with a simulated thing. At least that's a capability. That's part of the vision. It's currently not implemented, in case you wonder. And the monitoring things can gather statistics on what interaction has taken place with the things exposed via the hub. So when I say it's an edge device, this can run anywhere. So you could have, in a large environment, you could have localized instances of each of these hubs, and then connect to them from the headquarters. Or you can just place one in the headquarters and manage your network, so the hub can find all the devices. So the configuration is whatever you need. So what does it mean? What's a digital twin runtime mean? Well, it has a digital twin store, which basically manages the storage of all the status, the state, and the description of each of the things on the network. And the description of each of the things on the network, actually, there's two of them. The first one is the device itself. So the device creates a TD for that device. It could be a Z-Wave or Insteon or of any of these other third-party protocols whose bindings creates a TD to describe the device. And it could be a discovered WoT device on the network. The second one, TD, is that of the digital twin. So basically, it's a copy of the device TD, but all the protocol information is modified, because the consumer connects to the digital twin and not to the device. So all interaction takes place using forms and other stuff that the digital twin describes. Now, it also allows potentially the ability to route the digital twin to a different external device. So you can do A/B testing, you can do simulations, you can do other stuff. That's the potential that having a digital twin offers. The other thing is that you can add hooks for monitoring and other and simulation and other features of the device. Or you can just create virtual devices that don't really exist in the physical space, like an AI as a service that could interact as a thing. This is just the boring bit. So this is just basically a little detailed snapshot view. I won't go over everything, it's way too much, but it gives you, if you're interested in how the message flow works between consumers and devices, then this picture describes it. And in this particular example, it's how actions are flowing. So what you see on the left here is that you have consumers. It can use any WoT compatible client, because the hub, the consumer facing site, is WoT compatible. So it's with a TD in hand, which you have to acquire beforehand through discovery, invoke an action, and that arrives through the client at the transport server. And the transport server, of course, implements a particular protocol, and that can be many. Currently implemented is HTTP Basic with SSE SC, which is a variant. We'll get to it. And the WebSocket draft, the plan is, of course, not to leave MQTT out, and there's a bunch more in the planning. Once the core is fully stable, the intent is to load up with a bunch more transport protocols. The transport server is responsible for managing the connections. Most of these protocols are connection based, and it will forward basically it converts the messages sent by the consumer into one of three messages. Actions are captured in a request message. So all actions from all protocols are all converted to the same request message. So that means that the core doesn't really care what transport protocol is used. The request arrives at the router that then decides based on the request message. It can do some validation whether the consumer is authorized to access this thing. It can run through hooks. The actions are then updated in the digital twin store, which can keep a queue or a history of actions, and then passed on to the actual agent that manages the device that is addressed in the request. So that goes through a second transport server, out into over the network back to the agent that manages the device. And this again can be a protocol binding, such as a Z-Wave, or it can be an actual WoT device. The agent then responds with a result or an action status update that the transport server converts back to a response message. Similar to request messages, the response messages are standardized, unified. There's one type that captures the responses of all agents, of all type of responses. It's basically just a message envelope that carries a payload. But it allows the router again to store the result, update the digital twin store, and then converts it back to the consumer. Now, one thing of note, on the right side here, the communication with the agent uses the TD that is provided by the agent, while the communication through the consumer uses the TD that's provided by the digital twin. So that's the action flow. Now, if you like sequence diagrams, knock yourself out. It's basically the same story. The event flow is another type of flow instead of request and response. Events, and also that includes property updates. It's something you subscribe to as a consumer. So on the right-hand side, the consumer subscribes to using the WoT compatible ways and the transport server to the digital twin, subscribe to event or observe property updates. Again, the same idea. The transport server is responsible for managing the sessions and the subscriptions for that, as they are managed through that particular protocol. It performs authorization to make sure that the consumer is indeed allowed access to the events from that thing. And then it passes it to the digital twin router. Sorry, the subscription sites ends at the transport server. The agent publishes events or property value updates. The digital twin has subscribed to all of them. So all property updates and all events are sent by the agent to the transport server, and all of them are received by the digital twin that uses it to update the state of the device of its digital twin. Then it passes any events and property updates to the transport manager. The transport manager just simply has a list of all the transport protocols that are active and passes the events to them all. And then only subscribers will receive the notification messages. So inside, similar to action, the request messages and response messages internally, everything is just encapsulated in a message envelope of the notification message that carries the thing ID, the type of notification, the name, the payload, the timestamp, etc. So what was I going to say else about this? This whole mechanism, especially the protocol bindings and the messages, are a standalone package. So you could actually use them to build things with. You don't need to the hub, and that's at least how the design is intended. Again, for sequence diagram people that really enjoy these, it kind of describes step by step all the interactions that take place when an event is sent. So I mentioned earlier about services, so just a quick foray into some of them. And this is just a snapshot, and the ideas, the plugins, so you can add to infinity, or basically more dependent on how many people are actually contributing services. What is currently included is a launcher service, allows you to launch the start and stop services. A history, it gives you an event, past events. Currently, it only captures events, but there's nothing stopping it from capturing property updates or actions as well. HiveOT View is a little web browser, web-based UI, which I'll give a quick demo further on. A certificate services for managing hub certificates, because the hub has a couple of servers inside, so those have certificate. Currently, they're all self-signed, so the hub on startup generates a CA, first startup, that signs all the certificates for the servers. Provisioning, this is currently probably needs a bit more work. Intent is that devices, if you have many devices, you're not going to go to every single one to provision them. So the idea is to upload a list of devices with their credentials, and then they automatically provision. That mechanism, I have to look into what the WoT currently has specified. The current mechanism is purely based on HTTP, and should be adjusted to whatever the WoT standard is going to be for this. A monitor, which is not implemented, that's a future plan, but it's nice to have a bit of a view on the status of all things and their interactions and load and all that sort of stuff. And then there's a bunch of options to extend this. This is just a beginning. The other type of plugins, aside services, so services address many, apply to all the things. The IoT protocol bindings expose things. So the Z-Wave, Insteon, OneWire, Zigbee, CoAP, LoRa, there's a whole bunch of existing technologies that can be integrated through these protocol bindings, the IoT protocol bindings. The actual Web of Things compatible devices will also be incorporated through the IoT protocol binding, but it should be a fairly straightforward implementation because any published TD will just go straight into the digital twin. Whereas all the other ones, they have construct TD and events and property updates and handling of actions through a mapping for that listens to the messages, to the requests, applies them to the actual device and the underlying protocol, and then converts the result into events and property updates. The hub has some command line utilities included. There's 3 at the moment. The hub CLI is basically a command line interface to the hub itself. On the right, I don't know if you guys can read that, but it has commands for authentication. So you can add users, services, list them, remove them. It has support for the certificate. So all the services basically, if they expose the actions, there's some command line options to integrate to communicate with them, like listing directories, subscribing to event, publishing, subscribing to TD updates, etc. The second command line utility I use is generate Golang code from a TD, particularly the client-side interface, so you can get a native API to interact with devices that publish a TD or services, and a server, an agent side, so that if you implement a service or a thing, then basically it does all the mapping between the messaging and the native call to the server that actually implements the actions and emits events. This is currently used in the runtime. I can show you. There's a TD for the digital twin and the directory service and the service that manages all the values, authentication as well, and authorization. So the hub defines the TD and then generates an API for it. This was an experiment, but I found it actually works quite well and gets rid of all the boilerplate. You don't have to worry about it too much. Then the third utility is the vocabulary generator. It generates a vocabulary set of definitions into 3 languages at the moment, and that helps with standardization. And that's it's a bit of a I think a limitation currently of the ecosystem of the WoT as well, that there is no standardization for vocabulary. Like, how do you identify a thermometer? Most people just call them thermometer or temperature as a sensor or humidity, but there's no standardization in the vocabulary. So what this does is it takes a bunch of vocabulary and generates code for them, and then they can be used in building TDs. All right, enough talk. Let's do a little demo, and this will be quick, but it kind of shows you what's currently functional and the TDs that are involved. So in the services, this is provided through the HiveOT service, which is actually implemented in Golang, and it uses HTML and HTMX for interaction. So let's just. Now, I hope this is not too small. I've got a 4K screen. So what you see here is the dashboard. It basically picks from properties or events from a TD and displays the value it receives. So for properties, there is an API that says basically read values. So you can just pull up the value there, and that's standard exposed in the digital twin. So you could literally click on the value here, you get the past history. This comes from the history service. You can go to the actual thing, like the porch here is a thing. It's a multi-sensor on the porch. It's a one-wire device. It has an ID. This is the thing ID from the digital twin. It starts with DTW, that's just a convention. The OW server is the agent that exposes the device, and the C100, etc., is actually the one-wire device ID. So this is the way all digital twins are constructed, whose IDs are constructed. So the agent for the OW server, which is the one-wire server, it just exposes the thing ID with the native ID, while the runtime converts to a digital twin ID because the consumer talks to the digital twin and not to the native thing. This lists all the aspects you can find in the TD. It has attributes, their value, and when it's updated. It has configuration settings, the basically writable properties you find in a TD. It has events. This is a whole story about when to choose events and attributes. So we'll get to that in challenges. But as you can see, every event has a history. So if you want to see history, make it an event. That's kind of one of the rules. And it has an action. In this case, this device is quite simple, but it has a relay that you can control. Now, there's direct access here to the TD. I'll see if I can zoom in a bit. So this is a TD that is generated by the protocol binding for the one wire service. And what comes out of it, and yes, I know it's not fully compliant yet, because the forms are a topic of discussion. And right now, you don't really need them if you use the WebSocket protocols, but we'll get into that for a bit. There's nothing stopping here to add the full-blown forms as per specification, and that is the intent with the option to turn it off, because it does kind of bloat the TDs somewhat. So there's a context section like in every TD that indicates there's a version 1.1. There is an extension with the vocabulary for HiveOT. The add type contains all the vocabulary terms that HiveOT has defined. In this case, it standardizes on a format to identify a multi-sensor. That means the prefix is the vocabulary domain. It is it indicates, it defines a thing. If the thing is a sensor, and then more detail come, it's a multi-sensor. It has an actions, as you saw before. The action currently is the relay state. It is a type, again, from the vocabulary. It's an on-off switch. The idea there is now, you know, if you just want to find on-off switches, then you can just filter all the things that have an on-off switch based on this vocabulary type. That's the intent. But without standardization, this won't go far. That's my concern. It has an input, which is an integer, because the type, actually, I think, yeah, it has an integer type because this input can handle multiple values. The TD was created at a certain time with all the standard TD stuff. It has a description. There's a bunch of events that are emitted with a type, with the data that it carries, and a description of each of these. Each of these have a type again. Environmental sensor, it's a property of the device. It has humidex, humidity, and et cetera, et cetera. I've got one form section that indicates this is a WebSocket protocol, a sub-protocol. And in this case, for all operations. I'm not sure if this is standard, but that's a separate discussion. The whole form section is probably a thing of evolution. Now this thing is in alphabetical order, so now we get the ID. Here you see it's actually a digital twin thing. It has properties, and then you get a whole whack of properties. I'll get to that into a bit more detail into the challenges, but I was struggling with enums, and right now I'm choosing to use one-off of the TD definition specification to identify enumerations, because enums is just a value, and you cannot add things like default values or the constant value with a title, especially the lack of description. The ability to add a title that you can present is means you cannot use enums where you need a presentation. Yeah, these are all properties of the security definitions down below here. Is something I still need to fill in. So not fully finished, as you can see, but it's getting there. The HiveOT also, the UI here, HiveOView, also has a directory that shows you all the things and services. Now, here I'm struggling with some challenges for presentation, the information you need. I need to distinguish services from protocol bindings and from things. For ideally, you group things here by their capabilities, like sensors and actuators and services. So there's no standardization on this, so I'll have to switch to the HiveOT vocabulary to distinguish these and present them a little bit better than what you see here. So here currently this is grouped by agents, both services, like authentication has a service for administration and for user services. The administration, again, this is just a thing presented as a service as a thing which has attributes, configuration, and not in this case, a bunch of events, like user has been added and removed as an event. And you can perform actions that you can also see in the CLI. Now, of course, it's not just services. I'll go back to the directory. Like the one-wire protocol binding shows you all the one-wire devices it has discovered. That is the service itself. The IP gateway, that is the device I use. The gateway is pretty straightforward. It just plugs in a bunch of one-wire devices. It has channels. You can see what the data errors are and all the statistics it provides. And of course, you have the devices themselves. Which in this case is a simple thermometer, temperature sensor. Some type of protocol bindings work with a lot more properties. Like the Z-wave binding is rather extensive. Some of these devices, like the multi-sensor, has 120 properties and a bunch of events and actions. And if you zoom out a bit, go to the TD of that thing. So there's a whole whack of stuff in here that's just massive. And that is without forms. If I would add forms, it'd probably double. So you might wonder, well, how do you interact if you don't have forms? Well, it depends on the protocol. If you use, actually, do I have that in here? Probably just look for forms. Currently, this connects using WebSockets. So that's WebSocket protocol doesn't need all the forms individually, assuming you make some assumptions on the operations. And this is something that's currently we have some discussions on. And I'm making a lot of people unhappy by saying we should remove forms from TD, which of course is never going to happen. But at least we can reduce the amount of form information to what is necessary for the protocol you use. That's my hope. But at the same time, I'll add support for forms as intended, and especially if you use the HTTP basic protocol, you might need them. Because we're talking basically, all the consumers talk to this hub. So there's only one way to connect, and all the protocols are the same for all the devices exposed through that hub. So the sheer amount of power that forms brings are not needed here. So that is the reason I've left them out for now, but the intent is to put them in. Now let's see. I mentioned the Hub CLI. So just as an example, I hope you guys can see this. If you just run the Hub CLI, you'll see a bunch of commands, auth, certificate, directory. So, oh, look at directory.
Henk, are you showing the CLI? Because we are not seeing it. So
okay. So
maybe
then
you need to switch. Yeah.
Yeah. Let's see. For that, I stop sharing. Share window. Do you see a console?
Yes, that's
all right.
That's
Thank
nice.
you. Yeah. So the Hub CLI is more intended for administrators, or if you don't have a browser handy. So if you access the Hub on the server, this will provide some tools to have some insights what's going on. So a simple ls command lists you all the running services. Currently, that's the history, the web browser, the ISI, this is the stay on protocol binding, the one-wire protocol binding, the actually core runtime itself, and 2 Z-Wave instances, so you can run multiple instances of the same protocol binding as long as they have a different ID. So in this case, they are in 2 different locations. One is at the house here, and the other one runs in the in the shelter where the horses are. So keep track of the tech room and the pump house. Well, back to the pump house from the beginning, that has a Z-wave sensor and to indicate what the temperature is, motion detection, and the ability to control the heaters. Now, for example, if you want to see listed directory, you get everything. But if you want to list the directory of, let's see, a Z-wave device. This is the shelter. Let's see, I want to see the tech room, multi-sensor. Then this shows you basically the status. This is also an overview of all the TD of this sensor. This is a multi-sensor, so you'll see a lot of attributes here. These are the internal IDs as generated by the protocol binding, the description. There's of course more fields, but I would get a bit crowded. The current value, configuration, and events. And then, for example, if you want to subscribe to events from the command line, sorry, history of events. I might have to pick an event. All right, that example. Maybe I should pick a different device. There's a workshop sensor. Oh, demo gremlins, don't do this. I think the history service, it is the current status. History event. Yeah, that should have worked. Well, this isn't a proper demo if something wouldn't go wrong. Okay, I'll switch back to the web browser.
Yeah, we can try it again. Okay.
Yeah.
No worries.
Yeah.
HiveOT, there we go. This is back to the web browser. So what I wanted to show you is the Z-wave device. Stairwell sensor. Come on, workshop. There we go. You can see the events from the workshop, temperature fluctuations, etc. So this is visible from the command line. I'll just have to figure out why it was acting up. All right, that is it for demo. I'll switch back to the presentation. Can you see this?
Yes.
Yep.
All right, thank you. So the next section is about TD challenges. So there's a lot here, and I don't want to go into too many details, but I'm happy to discuss in Discord or something a bit further if there is some more additional curiosity. I'll leave 15 minutes for any questions. So we have 15 minutes to go through these. One sec. Yes, that's coffee. So these were the challenges encountered during implementation and design, or actually a rework of one of the prior iterations. And the gist of it is, if you have any prior existing system that you want to rework, my advice is to leave your opinions at the door, because that has really bugged me. I had expectations, and sometimes you don't really realize them about how things expect to work. And that is a hindrance. I think you're better off just take the time to read through the specs, which I did, but with a clean slate, no preconceived ideas about how it should work. And Ege is working on the how to use and how to documentation. Again, and other people, and that's probably going to be a great help, especially if you're developing things like IoT devices or hubs or gateways or any other WoT compatible devices or clients for that matter. So some of these challenges were because of ignorance, and some of them because the WoT currently doesn't really address these issues. And then you can have a discussion on whether it should or not. That's really outside of the scope here, although it doesn't stop me from pushing a little bit, because I think to address some of these concerns would help adoption to a big extent. All right, so I kind of have them 3 categories. One of relates to the affordances listed in the TD, so meaning all the properties, actions, and events definitions. And the first question I ran into is, what is the correlation between properties, actions, and events in affordances? Because you can have 3 types of affordances with the same name. The answer I got is there isn't any. It's okay. So with that answer, the question becomes, what does it mean if they have, or can they have the same name, and what would that mean? So the WoT, and correct me if I'm wrong, you guys, because you know better than I do. But it basically means there is no convention, no standardization. You're on your own. If you choose to create a relationship between these affordances, don't expect any interoperability or compatibility with clients. So with that said, I'm using this actually because it's needed to solve a problem. And there is no alternative to my knowledge. We had some discussion on it, but this is actually an interesting topic because every consumer will have to deal with this problem. Like, if you have an action, how do you get the result? How do you see the actions that affect the state of a device? How do you get the result? So, or how do you present the current state of that related to that action? Like if you have a switch, how do you show the current state of a switch? One option is when you present it to use read action to get the last action status, and you read its output, assuming that the output actually shows a state. The problem with that is if that state changes through another means, especially switches, they have often a manual component. A lot of actuators do. You can have a manual button on the device itself, and that would not be reflected in the action, but it would be reflected in a property that reflects the state. So as an example, the switch, you would have a switch in the property, an on-off state or whatever label you give it. But then there is also an action that controls that state through the TD. But there's also an option to control that switch manually. Now, the only way I found to link that together is to use the same name for the property and for the action. So I kind of nicknamed that twin affordances. If you have twin affordances, that means they have the same name. They apply to the same state, or the same action affects that same state of the device. This is a choice in HiveOT. We'll see where it goes. It's a bit of an experiment, and I actually hope this use case is adopted because it's a problem that has no other existing solutions. There are some discussions about linking actions and properties, but nothing is specified. The other reason to do it this way is that it would be kind of confusing to say, well, I've got this property with this name, and then I've got an action with the same name that does something different. You would probably avoid that altogether. So in that case, it makes more sense to adopt it, embrace it, and say, let's make use of this to improve the interaction, the capabilities of the interaction. So this is what HiveOT does, but again, as a warning, this is not a standard. As a side effect, as a point aside, there is no standard all whatsoever. So this is still compatible with consumers that don't make that assumption, because these consumers can present the property and invoke the action. There is just no standardization that the action affects the state of that property, so you can use it for presenting the current state. Let's see. So yeah, this is my talk about actions actually. This is another discussion related to the same thing. If you have action, when do you choose actions versus properties? Because there's two ways to control an input. Again, let's go back to that switch. The switch has an input. You can turn it on and off. Simply put, you have demos and you have all sorts of actuators that have input controls, right up to valves or aircos or fans or all sorts of other controls. When you make a control of these actuators an action, and when you make them a property. So we had some discussions on as well, and going back and forth. There's no standardization on this, and there's no guidance. So I had to make up some rules, and you hear different recommendations. Some people say, well, just use actions. Sorry, just use properties. And a recurring theme in this, it depends on state. Do you affect state? So what makes it an action? The rules I have is if it triggers an actuator, it's an action. I don't know what the original terminology, the people that defined it had that in mind, but it kind of makes sense purely on the vocabulary name. If a person performs an action on a device, it's an action. So let's call it an action, not a property. Similarly, if you would have chosen properties to control an actuator, well, some actuators just have like a push button. There is really no input, and some actuators have multiple inputs. You can't do this through a property, at least not intuitively. So those would have to be an action anyways. So the very clear choice here. If it's an action for the user, it's an action in the TD for all the HiveOT things. It mimics behavior in the real world, users act, etc. Now that doesn't mean they have a property. No, well, yes or no property. All internal state of a device is represented through a property. That is the other rule. So if you have an action that affects the internal state, there will be a property that presents that state. And in this case, if it's a single property, it will have the same name as the action. And again, switches, most actuators would have events generated or state updates if they are manually controlled. Now, a related discussion. Oh, now we have events. When is something an event? When is something a property? See, both you subscribe to in a way, and both you have state. The only difference is in the TD, you can read property values, but you cannot read event state, the last events. Although some protocol bindings do, but there is no operation in the TD defined for this purpose. So, and that raises all sorts of questions, right? When does a light switch status change, a property or an event? See, if you control everything through the TD or through the thing, you could do a property because there's no magic here. But in case of a switch that also has a manual control, a status update, is that relevant? Should it be an event or just a property? The same with temperature sensors. So there's no right and wrong or black and white here. It's just a choice. So in HiveOT, I've said the distinction between an event and a property is that an event shows external state changes, whereas properties reflect an internal state. They can coexist, so you can have both. But the moment an external state exists, and like a temperature sensor is an example, the temperature is a state of the environment. So it's not a state of the device. So therefore, a change in temperature is an event. The same with a light switch. A light switch that has a manual control by a consumer is a change for it, for the manual control, would be an event. And that leads to triple affordances, which you currently have not implemented, but because I thought, well, maybe this is a little bit over the top, but it's logical, and I haven't found any reason not to. So if you can apply this consistent, it makes a lot of sense. And that goes for all environmental sensors and actuators that are manually controllable would have an event, a property, and for actuators, an action. Is there anything wrong with that? Some people might find it overkill, but on the other hand, if you consume a TD, it's for a consumer very logical. And I think we need to make the design decisions to facilitate the consumer, not the device developer. Not that it is so much extra work. So we're already at 15-minute mark. I'll just sneak in 5 more minutes.
Yeah, don't worry. I think we can go on.
Okay. So there's also a discussion of how do you get a result of an action? So there is, currently, it depends on the protocol binding, and I didn't like that. Because as a hub, you have to propose something consistently to the consumer. Yes, it can be done, but it would be a different exposure, different interface to the consumer. So the other thing is that actions can have transient states. An action has a rest state, and then it has a state where it's transferring to the intended result. And like valves and blinds, they don't switch immediately like switches. Even switches can take some time. And by the way, this only applies to actions that affect stateful things, like an RPC call, like for example, read the TD, is an action that has instant results. So this doesn't have the state aspect. So and that's the second point. Any read data request would have no state affected on the device. So in both cases, you can have output. For stateless actions, that's the whole purpose of the action, to retrieve results. So the HiveOT solution is to standardize the action status object. The HTTP basic protocol definition has defined one, so that's basically what it's derived from. But in this case, I'm adding a little bit more, and that's a discussion with Ben as well on the WebSocket protocol. Whether we need an action status or you can just simply return a result. So I think that's still a little bit fluid. In this case, HiveOT says, as a consumer, you always get to see the action status result, although the protocol in the interim might do something different to it. So that means that the transport protocol binding will have to do some mapping. But internally within the hub and externally through generated APIs, you have a consistent interface that the result of an action is always an action status. That means that if you, and the same goes for a reading action, if you read an action, you'll get an action status that contains the input, output, and the status, whether it was failed, an error, or nothing. The only discussion left here to me is, should the output, the immediate output of an action just contain the output value or an error, or should it contain the action status? That I'm on the fence on. One thing though, in order to correlate actions request with the results, you would need something, and that is the correlation ID. So that's, unfortunately, it's protocol dependent. But as long as all protocol supports it, which HTTP basic doesn't define, that means that you cannot return asynchronous results, which HTTP doesn't support anyways, but then you could use SSE, which is even more limited. So I'm more thinking towards WebSocket and MQTT and other connection-based protocols that have the ability to return results. This is a long topic of discussion, and we don't have time for this to go into further depth. My preference is to standardize this at the WoT level, similar to how you define the TD. I think it's okay to define some standardization like message envelopes for requests, responses, and notifications, and action status. And this is something that you guys can probably consider out of scope, but within the HiveOT I've standardized this. So that means that they act as all these message envelopes are simply a payload you send over HTTP, MQTT, or WebSocket. You might ending up with a new unofficial protocol binding that just does that and then leaves the message format as is. The GitHub has them defined. So if you want to know more, let me know. I'll send you a link. The other big challenge was, I've touched on that before, what's the meaning of a property? And this is where vocabulary comes in. So I've defined some, but ideally the WoT recommends some standard vocabularies to be used so that all devices that implement that are WoT compatible has support for these. It's otherwise everyone does their own thing, and then you still have no interoperability. Enums, I touched on that. Multi-line descriptions, yeah, there's some improvement that can be done. Currently, each affordance can only have one line description. Sometimes that's not enough. Same for comment fields. Maps, this is a bit of a pet peeve. I was trying to figure out how to define a map in the output of a TD schema. And this is what I figured out it has to do. You define it as an object that has property, and it's only one property, which is an empty key. This was like, holy cow. So I kind of really propose to add a map type. You have an array type already, why not add a map type? And then the properties can just be the object that is mapped, and the key is implicit or something like it. But anything a bit more intuitive than this, please. How to read the last event value, that's not supported, but in HiveOT added some operations to say read event, just like you have read property and read action. Yeah, it's non-standard, but if you talk to the hub, you'll have it. The other option is that if you subscribe to events, to always send the latest one, but that's not a standard either. So that's a bit of a conundrum. Or have a property for every event. Then basically you just read the property. That's also an option. So there's options and things that are not quite settled yet. Instance, yeah, anything shared, that also goes for data schemas. There's no way to share even between affordances. I kind of used the schema definitions in the TD to reuse it, and then instead of data type, the native types, and affordance would be able to use the name of a schema definition. Not standard, but very easy, very useful. If you have an action or properties that or events that return the same data type object, then it's you can put schema definitions in it. This is something I think might be worth considering, or you guys might think, yeah, it's way too much for a WoT thing. Okay, all good. I find it useful. And then maybe you could find a way to do the same, but then between schemas, between TDs, because all the TDs provided by a protocol binding might have some stuff in common. And it would be nice to be able to share that schema definition. All right, next section, forms. Well, I think we're out of time, just in time to be out of time. This is a very interesting discussion. I have created an issue that says get rid of forms. That made a lot of people unhappy. So I toned it down a bit and say, let's find a way to move it out of the TD or limit it to what is necessary for the protocol binding you use. And I think there's merit there, as long as it's backwards compatible with all. And that basically means that the HTTP basic would still be able to have a form for every affordance, and that's fine. But if you have a WebSocket connection, any connection-based protocol typically have one connection for a device. So you wouldn't need to create affordances, forms for every affordance, especially if you use thing-level operations. The ability to do something like that, which is currently not supported in TD 1.1, and probably I doubt TD2 will have that fully hashed out, but I think there's a room for simplification there. It's very powerful forms. You can basically define a whole protocol binding for every single affordance. There probably are use cases because of the reason that that's possible. I think many cases for the devices I've encountered, it's way overkill. Unfortunately, it really complicates both the consumer side and the thing side having to do this. So I think there's some room for simplification there. SSE, yeah, I've got an SSE version that works with HTTP basic that returns basically that transfers a request, response, and notification message envelope as the payload to be able to support multiple events and multiple affordance messages over a single SSE connection, because it's the same issue. So this obviously is not in accordance to the SSE standard specification, WoT specification. So hence, there was a challenge here. I worked around it. It doesn't mean everything is WoT compatible right now, but I see it more as an evolution to become this way. Let's see what else. Yeah, there's a lot related to forms and a discussion on message envelopes, which I kind of really propose to have message envelopes and just use that as the payload for transport protocols or message protocols. Let's see, I'll just quickly go through it because we ran out of time. Authorization. So yeah, there's some more stuff to do to really make it fully interactive. But I think I've got a core now in HiveOT that lends itself to evolve towards fully interoperability. I think the main focus now is to provide interoperability with consumers. So that will be the next steps, and then start adding services once everything is solidified. I made a lot of iterations, so there's a lot of changes and there's a lot of rework, and all the test cases have to be adapted. I've kind of think this happened enough now to really know that what I've settled on now with HiveOT is a decent way of approaching this. All right, that ends the presentation.